This is a catch-up lesson. We're going to talk about isomers. We're going to talk about polyatomic ions, Lewis structures. For polyatomic ions. And exceptions to the octet rule. Isomers. If you have large molecules of 7, 8, 9 or larger atoms, you have large molecules, it is possible to have more than one correct, following all the rules, structure. Correct structure. They have the right number of valence electrons. They have A is great, 2 is 2. Everything's fine, but you can rearrange the atoms to get something completely different. So large molecules, 7 or 8. It's even the more atoms you have, even more and more isomers there are. So it expands greatly. Lewis diagrams for polyatomic ions. Remember what a polyatomic ion is? It's a covalent. It's more than one atom with a charge. The atoms are covalently bonded with electrons added or subtracted. So you have additional electrons added to it, or some electrons are removed from it. NO2 minus nitrite. Nitrogen has 5, 2, 3, 4, 5. There are 2 oxygens. Now, every atom has 7 electrons right now, so what you do is you combine, make double bonds if you can. So the right-hand side oxygen has 8, the middle nitrogen has 8, but this oxygen out here on the left still has 7. Fortunately, there is an additional 1 negative electron that you can add in at the end. Since these are ions, you have to put it in a square bracket with a charge. So, general rule for negative ions, you draw the structure and you get down to as few electrons as you can, doubling up bonds, and then you add electrons, add dots at the very end when needed, when and where needed. Positive ions, positive polyatomic ions, you do the opposite. What you do is, instead of adding a negative electron, you're going to remove a negative electron to make it a positive. And you do that right away. Nitrogen normally has 5, but we're going to go with 4. And then you're going to have to add 4 hydrogens, and now you got 4 spots for the hydrogens to occur. Which they can. Everything's hooked up, but it is an ion. So you do that. Now, if you were to write the formula for ammonium nitrite, this is like we did with, say, sodium chloride, where you had the square boxes for the sodium and chlorine with 8 dots around it. Same thing here. Ammonium, the polyatomic ion, which we did already, so I'm going to write it down without explaining it, and the nitrite, which we've written already. And that's what we have. The pluses and minus signs, you don't put them in because the 1 plus and 1 minus cancels out and you get a neutral substance. So that's how you would write polyatomic ions in a compound, in an ionic compound. And this is polyatomic ions with adding and subtracting them. Okay, last thing is exceptions to the octet rule. Small atoms must have less than 8. The reason for this is they're small, they have a very small surface area, and there's not enough space for 4 electron clouds or 4 orbitals to fly around it. So since it has a small surface area, you have to have less than 8. Helium or hydrogen we already talked about. The other 2 elements that have less than 8 is beryllium. It has 4, hydrogen has 2, beryllium has 4, and boron has 6. Those are the only small ones that covalently bond that you have to worry about. Helium has only 2 atoms around it, but it doesn't bond with anything. Lithium, when it bonds, it loses an ion or electron to form an ion, so you don't have to worry about how many valence electrons are around, how many shells around it. It's the way it is. Okay. So small atoms must have less than 8. Large atoms may have more than 8. 8 is still optimum. If you can get away with 8, go with 8. And this is because they don't have a small surface area, they have a large surface area. They are so big that you can attach possibly 10 or 12 electrons around it. It can have 5 or 6 orbitals attached to it around it. And these large atoms are defined as phosphorus and above. Any atom with an atomic number of phosphorus and above, so phosphorus, sulfur, bromine, things like that. And the last exception is odd number of electron molecules. These are extremely rare, and when they do exist, they are extremely reactive. They tend to want to combine with any molecule available to add an electron and turn it to some other molecule. They are stable, but very reactive. They're commonly found in smog. That's why one reason why smugglers are dangerous is you breathe these in, it reacts with the moisture in your lungs and turns into nitric acid, which is generally thought to be a bad thing. That ends this lesson. That wraps up isomers, Lewis structures, and exceptions to the octet rule.